Assalamu alaikum dear students. In previous video lecture we discussed how to find the limit of a polynomial at a point. That is, if we consider p of x equals to a naught plus a1 x plus a2 x square plus so on to a n xn, which is the given polynomial, then the limit of this polynomial at x equals to c is simply replacing x by c, that is p of c. So p of c is the limit of p of x at x equals to c. Like if we consider x square plus 2, it is the polynomial, and we are asked to find the limit at x tends to 5, which implies that we have to replace this x by simply 5, that is 5 square plus 2, which is 27. So 27 is the limit of this polynomial at x equals to 5. Now today we are going to discuss how to find the limit of a rational function. You know that rational function is of the form of px upon qx, where p and q are the polynomials. We know that the limit x tends to this a, p of x upon q of x is simply limit x tends to p of x upon limit x tends to q of x, if limit of this denominator not equals to 0. But these two are the polynomials, so their limit is simply p of a and q of a. That is, limit x tends to p of x upon q of x is simply p of a upon q of a, provided q of a is not equals to 0, because by the concept of limit at a limit of a polynomial and the algebra of the limits. Like if we consider x square plus 2x plus 1 upon x plus 1, now the limit of the denominator is simply 1 plus 1, that is 2, which is not equals to 0. Hence limit in this case exists and is simply by replacing x by given number, that is 1 square plus 2 into 1 plus 1 upon 1 plus 1, that is simply 4 by 2, that is 2. Now we will discuss the different cases. Here we discussed this only when q of a is not equals to 0. But when q of a is 0, q of a is 0. If q of a is 0 and p of a is not equals to 0, numerator is not equals to 0 and denominator is 0, then simply in this case we say that the limit does not exist, because 1 by 0 is not definite or 1 by 0 is infinity, which implies that limit does not exist finitely. Now when q of a is 0, this means that x equals to a is the factor, or x equals to a is the 0 of this polynomial. Hence we can write this q of x as x minus a into r of x, where degree of r of x is less than degree of q of x. If p of a is not equals to 0 and q of a equals to 0, so this means that it is finite upon 0, which is not definite. Hence limit does not exist in this case finitely. But when p of a is 0, this means that we can write p of x as x minus a raised to power k r1 x, where r1 a is not equals to 0. It is a polynomial whose degree is less than degree of p of a, and q of a equals to 0, which implies that we can settle right q of x as x minus a raised to power n into r of x, while r of a is not equals to 0. Now hence we can write this rational function as limit x tends to a p of x upon q of x is limit x tends to a x minus a raised to power k r1 x upon x minus a raised to power n or into r of x. Now when this k in the numerator is greater or equals to n, like in if k is 5, n is 5, or if k is 5, n is 2. So this means that k is greater or equals to n. Then when k is greater or equals to n, we can cancel the terms from this denominator, that is x minus a. Like here if we have x minus a raised to power 5 and in denominator we have x minus a raised to power 3, then we can cancel this x minus a raised to power 3. So when we cancel it, we get x minus a raised to power k minus n into r1 x upon r of x. So limit is simply then by simply putting x equals to a in the given equation, which is simply 0. Like if we consider x square minus 1 upon x minus 1, Now these are 1 square minus 1 upon 1 minus 1, that is p of 1 is 0 and q of 1 is 0, which implies that we can write this as x minus 1 into x minus 1 plus 1 divided by x minus 1. So cancelling this x minus 1 and x minus 1, we simply get x plus 1, which is simply 1 plus 1, because x plus 1 is the polynomial. Its limit is simply by putting x equals to 1 in the given equation, which is simply 2. Or if we consider x minus 1 upon x minus 1, x square minus 1 ka whole square, that is x minus 1 upon x minus 1 square into x plus 1 square. Now this x minus 1 cancels, so we get here 1 upon x minus 1 into x plus 1 square. So it is of the form of this very first case, where denominator is numerator is 0, numerator is non-zero, and denominator is 0. So this means that limit does not exist finitely. So these are the cases through which we can solve the limit of a rational function. Now here note, if p of x equals to x minus a raised to power k into r of x, where r of a is not equals to 0, then this x equals to a, or simply a, is called as the 0 of this polynomial whose multiplicity is, or with multiplicity is k. So this means that its multiplicity is k. Inshallah, in tomorrow's video lecture we will discuss some standard limits. So thank you.